So, you got this graph ready to go. Let's graph again sine theta. Okay. So theta, sine theta. The inputs I'm going to use are going to go from negative pi, then negative pi by 2, 0, pi by 2, and pi. Okay. What is sine of negative pi? You guys are writing this down. Sine of negative pi. Anybody? What's sine of negative pi? Well, there's so many ways you could do this. Well, why would you want to do that? Well, it doesn't even matter. In any case, sine of negative pi, I'm thinking too much. Sine of negative pi means that you're going to go negative pi. So instead of going up, you're going to go down. And that's negative pi. If you're going to go this way, negative pi is here. So what's sine of negative pi? 0. So it's going to be 0. Sine of negative pi is 0. What's sine of negative pi by 2? Go negative 1 because we're going negative pi by 2. Negative pi by 2 because we're going down. So this is going to, and we land at this point by going negative pi by 2. And it is negative 1 because it's negative 1 to y. So this is negative 1. Alright, so this is negative 1. Sine of 0. What's sine of 0? Come on, people. Sine of 0. 0. Sine of 0, 0. Sine of pi by 2. Sine of pi by 2 is what? 1. So this is 1. And then sine of pi. What's sine of pi? 0. So, I mean, we're doing this, something we already did a lot before. Plot the points. Negative pi is 0, and then you got negative pi by 2, which is right here, is negative 1, and then you got 0, 0, and then you got pi by 2 is 1, pi is 0, and connect these dots in a curve because you know it's a wave. It's a wave thing like this. So we're going to find the inverse of this function. To find the inverse of this function, all the inputs become outputs and the outputs become inputs. And that's what I'm going to do over there on the right side. Switch the inputs with the outputs. So all those outputs become inputs and inputs become outputs. All right. Just by looking at the table here, on the right table here, you got big problems here. Because for this to be a function, right here, as it is, for just going from negative pi to pi, and then we switch them. This is not a function as it is on this interval. Why is this not a function? Anybody? Why is that not a function? Do you know what a definition of a function is? Look, a function, like a linear function, a line, a quadratic, a rational, any exponential, they're all functions because For every input, it has one exact output. It has one exact unique output. So, am I going to even talk about this? It's kind of, I don't know if it's correct to even talk about it like what I'm gonna say. Yeah, I don't know. It's not good. Probably not say it. Like, yeah, kind of like for here. This is a function because for every input it has an exact. For every input it has one unique output. For every input it has one unique output. The problem here is that for this input of 0, yeah, 0, for this input of 0, has an output of negative pi. And this input of 0 has an output of 0 again here. And this input of 0 has a pi output, not a function. It's not a function. And okay, let's graph this. Let's graph. Let me graph it. So if we graph 0 goes to negative pi. Where is negative pi? Like right here. This is 0 goes to negative pi. Negative 1. Okay, this is still going to be x and this is y. Negative 1 over here. This is negative 1 right here. Negative 1 goes to negative pi by 2. Negative pi by 2 is like somewhere right here. 0 goes to 0. 1 is here, goes to pi by 2. Pi by 2 is here. Somewhere a little higher, right there. And 0 goes to pi. It's over here. So if I graph this, it's going to go like this. Okay. So this is the graph I'm getting by switching the inputs with the outputs and the outputs with the inputs. Why? I don't know if you guys did take algebra 1, and I don't know how in depth they went about what a function is. It's called a vertical line test. Another way of looking at it is if you do a vertical line here, it's going through 2 points already, this and this, so it's not a function. And if I do a vertical line here, it's going through 2 points here, it's already not a function. And even if I extend it and I continue on with the graph, it crosses it in an infinite amount of times. Definitely not a function. I have to cut this so it becomes a function. I have to cut parts of it. So how do I cut parts of it? What would be a good thing to cut? See, so it becomes a function. What I'm going to do is if I keep cutting it, I'm going to cut this part. I'm going to cut this. Still messed up right here. I'm going to cut it. I'm going to cut it. I'm going to cut it all the way to there. And I'm going to cut it all the way to there. Now this is a function. This is a function. Because for every input, it only has one output. For every input, one output. For every input. Okay. So when we do this, and I do that, and I have, that's the graph, I'm going to focus on that square right there. That's going to be the function. There it is. So the inverse of sine, this graph right here, this graph right here is sine inverse. This graph right here. So we can call it f of theta equals sine inverse of theta. F of theta equals sine inverse of theta is this graph right here. Like we did with the sum and difference formulas, the ones we did last week. I'm not going to do it for cosine theta. It's the same kind of idea here, and we got to cut it, the cosine function. So we'll just do it for sine function, the sine function. What would be then the domain? Let's go. What's the domain of this particular function? Anybody? What's the domain? The domain is all the possible inputs. From where to where? It looks to be negative 1 to 1, because this is 1 to 1. So the domain, I think, including negative 1 to 1, is the domain of this function. And the range will be what? Of this function. What's the lowest it goes? Negative what? No, it's this number here. Negative pi by 2. All the way to pi by 2. I mean, in the next slide I have all this, what the domain, what the range is for this. So what does this mean? Well, when we'll get to it, I have the domain and range already in the summary of it. All right, I'm gonna move on. Moving on. There it is. Negative 1 to 1 domain. You see it? Negative 1 to 1. The range. Negative pi by 2 to pi by 2. Negative 1 to 1, the range is negative pi by 2 to pi by 2. Meaning that solutions for sine inverse will be found from negative pi by 2 to pi by 2. It's solutions, we're going to solve functions in a minute. For sine, they're found on the right side. Solutions, it makes sense for sine inverse, are found on the right side. For sine, or just, solution on the right side. Let's see. Cosine looks like that. What the heck? Does it? I guess. So this one goes like that, then the other one goes like that. Okay. But look at the domain. The domain does go the same, negative 1 to 1, but then it goes from 0 to pi, not the other one. So the domain, it is negative 1 to 1. But the range goes from 0 to pi. What does that mean again? It's going to be found on top of the x-axis. Solutions for it will be found on top of the x-axis. And it will make sense when we start doing problems. Solutions for cosine inverse are found on the top of the x-axis. I don't know. So I'm just looking at sine inverse I and right. So I and I, the right side of the act, and then O for up top, the top side of X, the X-axis. Just to remember. But I mean, I don't know, some connections on where, how to find solutions. I'm gonna move on, and if you didn't get everything, you go to the website and get it. Moving on. All right, here we go. Evaluate the following expressions. 1, sine inverse of that. What you need to understand here now is that they're giving you the sides of a triangle, the ratios of the sides of a triangle, and now they're asking you what is the angle that gives you that ratio. So you're looking for an angle. And the way you do this easily is by bow tie, drawing a bow tie. Just draw a bow tie, whatever, some bow tie. Whatever, it's okay. So you draw a bow tie. Solutions for sine are going to be found where? Right. That's why I for right. So it can be. So definitely you're going to get rid of this left thing. Now it's like a process of elimination. So is it going to be the top one or the bottom little part of the bow tie? It couldn't be the top. Why couldn't it be the top? Because this is all positive right here. And what is this? So it's got to be this. It's a process of elimination here. So it's got to be the bottom one. So now we're looking at here. So now, it's going to be this. Right angle. So what's the definition of sine? The definition of sine is what? Opposite over what? So katoa, opposite over the hypotenuse. So this is going to be O over H, where opposite is going to be negative root 3, and then hypotenuse is 2. So what is this angle? Man, if I have not said it so many times. 60, opposite of 60, 60, 3. No, it's 31. 60, up to 60, 63, radical 3. So this is better be 60. This is 60 degrees. But it's what? Because it went down, it's going to be what? Negative 60. So negative 60 is how much in radians? What's 180 divided by 60? What? It's pi by 3. Negative pi by 3. The answer to this is negative pi by 3 is the answer. So what sine inverse on negative root 3 over 2 is negative pi by 3? Yep. It only has one solution. It should be negative pi by 3. It's negative 60, but it's negative pi by 3. And that's all there's to this. Let's go cosine. Go. The passage just go. You good? Take too long. Let me see. Let me get a pass. So draw a bow tie. Where's solution for cosine found? Cosine inverse. Cosine for what? Top, isn't it? Top. So you're looking at the top. Left or right? To the right, because it's positive. So it's going to be the right one. Then what's the definition of cosine? What's the definition of cosine? Opposite? No, it's not opposite. It's what? Adjacent over hypotenuse. So adjacent is down here because you're standing at the origin. This is root 3, and this is 2. So that makes what? The opposite be what length? What's the up and down? What's the length of it? 1. So that gives it away as to what is the angle here. What's the angle here? 30. Because it's 31, no? That's always 31. So if it is 30, what is 30 degrees in terms of radian? Pi by 6. So the solution is pi by 6. All right, continue. Okay, number 3. What is the sine inverse of sine pi by 6? Okay. Let's do the inside first. What's pi by 6 in degrees? Which is the way you did it. 30. What's sine of 30? Man, if I said if you by the end of this chapter, if you don't know what sine by pi by 6 is, just by like 1 plus 1 is 2. Sine of pi by 6, sine of 30, 30 is 1/2. This is 1/2. Sine inverse. Sine inverse. Sine's found where? Sine is found on the what? Inverse found on the right. So is it going to be the top or the bottom? The top. And then sine is, the definition of sine is opposite. So what's the answer? Pi by 6, isn't it? Yes or no? It's giving you the 1/2. What angle gives you 1/2? And it's pi by 6. So you're getting it back. So yeah, they undo each other. Well, you're asking, well, why are we doing all this work if they undo each other? They don't always undo each other like that. So yeah, they cancel each other out. The answer is pi by 6. Degrees and it's pi by 6. All right. Hopefully this one will be like, okay. So well, you're looking at a cosine inverse with a sine, so they don't necessarily undo each other. Yeah. Okay. So. What sine of pi by 3? What's that in degrees? I don't know. I always change it to degrees just because it's 60, no? Sine of pi is 60. Sine of 60. What's sine of 60? 60. What's sine of 60? Root 3 over 2. So this is root 3 over 2. Sine of 60 is root 3 over 2. But now we're going to find the cosine inverse of root 3 over 2. Okay, see, here's where it changes. Why does it change? Because now we're looking at this. What's the definition of cosine? Cosine is what? A over hypotenuse. So that root 3 has to move over here. And then hypotenuse is over here is 2. So that puts this to be what? This is going to be 1, and that makes this what? 30. 30. So 30 is pi by 6. So it changes to not that, but pi by 6. Did he get the answer? Did he even? Oh yeah, it's 30. 35 by 6. Try to use more radians than this. I don't know. I have it in a PowerPoint like this, but you try to change it always to radians. Okay, number 5. Where do you find solutions for tangent? Tangent inverse. Tangent inverse, where do you find solutions for tangent? Just from remembering, I think it's also on the right side, the same as sine. Let's just do it. Let's do it. You know, figure it out. So the definition of tangent. What's the definition of tangent? O over A, no? Isn't it O over A? Opposite over adjacent. So draw a triangle. I don't know. I just do it here. It's positive. It's just gonna either be there or here. So it is on the right side, and this is positive. Everything here is positive, and so yeah, you have to remember how this is gonna work out. Let's see. Because opposite it says is root 3. All right, let's put it there. Root 3. Opposite is root 3. This is 3. How the heck is that going to be like that? So what is this? And then what is this? How are we going to do this? 31. See what happened? You have to remember what this. It has been rationalized. So really, this is going to be this. Just make that connection. I don't want to even explain more about it. It's really this that has been rationalized because we multiplied root 3 by the top and the bottom. That's why you get root 3 over 3. So really, you're looking at tangent inverse of 1 over root 3. So then that leaves the opposite be 1. So this is 1. And this is root 3. For what I've been using, no? Because that's where I've been using it. And 2. Now it makes sense. So what is that? What's the angle? What's the angle? 30, 31. So it's pi by 6, no? So, what's cosine of pi? What's cosine of pi? Huh? -1? Cosine of pi is -1. It is -1. So tangent of -1, tangent inverse of -1. What's tangent inverse of -1? I'll give you extra credit right now if somebody says it. Who's gonna say it? Come on, what's the tangent inverse? What's tangent inverse? Nobody? So tangent inverse, the same as sine, would be found either it's on the right side. It is negative, so it has to be found in this quadrant here. The only way that this is going to happen if it's a 45 degree, because then that makes this what? -1, 1. Root 2, and so that would be tangent inverse would be what? O over H, which is going to be -1. Yes? Yes or no? Huh? Is this too fast? Or is it? So there's that. Okay, we're done.